Hi friends, so now we will see a t-test that we have in our statistics. So what basically happens is when we compare the population parameter, right, such as mean of a single sample of data collected from single population, then that is our basically sample test. So that happens very rarely when we know the variance of the population, right? So a common strategy to access hypothesis is to conduct a t-test, right? So a t-test can basically tell whether two groups have the same mean or not. Okay, so basically we have two type of t-test. One is one sample t-test and another is two sample t-test. So we assume that the sample are randomly selected, okay, and independent and come from a normally distributed population with a known but equal variance. So let's see with example. So first is we have t-test, right? So this is the case when sigma of the population is unknown. Okay, so this is the description that Experian marketing service reported that the typical American spend a mean of 144 minutes, okay, that is 2.4 hours per day accessing the internet via a mobile device. So that is the source, the 2014 digital marketer available at EXPN. Okay, so that is nothing but exponential. Okay, and in order to test the validity of the statement, you select a sample of 30 friends and family, and the result for the time spent per day accessing the internet via mobile device in minute are stored in internet mobile time. Okay, so A is there evidence that the population mean time spent per day accessing the internet via mobile device is different from 144 minutes. Use the p-value approach and a level of significance of 0.05. So what another is what assumption about the population distribution is needed in order to conduct the t-test in A, right? So the problem 9.35 from the textbooks adapted for classroom. Now we import the necessary library, that is NumPy, Pandas, Math, and that is Stats from SciPy, right? And this time we are importing t-test with one sample. Okay, so this is the data set that we'll be using. I'll provide it in description as well. So this is the head, that is we have one column minutes, okay, and these are the values. So what it is telling that there are steps to solve with one t-test. So that is define null and alternative hypothesis. So this is very important. We define h0 and h1. So in testing the average minutes spent on the internet, right? So null hypothesis states that the mean internet uses time. Okay, so in our case it is 144, and alternative hypothesis states that the mean internet uses time, right? So mean internet states that the mean internet uses time. So in this case it is unequal to 144. Okay, so this is the representation that we will do. At 0 that is mu is 144, and H A, that is alternative hypothesis, which is mu not equals to 144. So now we have to decide the significance level. So here we select the alpha as 0.05. So now what we are going is we are saying that the sample size for this problem is what is the length of my data. So in our case it is 30. So the next step is to identify the test statistic, right? So we do not know the population standard deviation and n equals to 30. Okay, so we use the t distribution, and the t stats is nothing but our test statistic. So now we calculate the p-value and test statistic, right? So that is nothing but for one sample, and that calculates the t-test for the mean of one sample given the sample observation and the expected value in the null hypothesis. So the function return t statistics and other two-tailed p-value. Okay, so this is our one sample t-test where we have t statistics, this and the value. This is we got from our t statistics and p-value, which we applied in the t stat one sample, right? So let us calculate at the value of the test statistics manually. So here we see that the values of test statistic and the p-value is same as that we calculate from the function of the SciPy library, right? So now the fifth step, we would say that to decide to reject or accept the null hypothesis, right? So this is our ultimate goal, whether to accept it or reject it. So in our case, if p-value is less than 0.05 and greater than alternative hypothesis, so how we'll get that? We are first defining alpha value, right? So then we are telling that okay, this is our level of significance, right? So this is what we got from here, and we are telling that if p value is less than alpha value, right? So whatever the p value is, if that is less than our 0.05, then we have the evidence to reject the null hypothesis, right? Just because p value is less than our level of significance. Okay, and if that is not a case, like if p value is equals to alpha value or p value is greater than alpha value, then we can say that we have no evidence to reject the null hypothesis, since our p value has become greater than level of significance. So one thing to keep in mind, that we never say clearly that we are rejecting this or we are accepting this, but instead of saying that, we say we have no evidence to reject the null hypothesis and we have evidence to reject the null hypothesis. Okay, so please have these things in mind. So this is what we got, level of significance, and that is the evidence that we do not have, and our one sample t-test p-value we got from p-value, which is nothing but 0.23. So in this example, p-value is 0.23, right, and it is greater than 5% level of significance. So the statistical decision is failing to reject the null hypothesis, right? So this is the accurate term that we use, whether it accepted or rejected. So just it is failing to reject the null hypothesis at 5% level of significance. So at 95% confidence level, there is sufficient evidence to prove that mean time spent on the internet is equal to 144 minutes, according to our this example that we discussed, right? So thanks, have a good time.